All right, so I'm looking at my second example of projectile motion, which again just means something's moving not in a straight line in terms of it's moving both up and down, left and right. And so, well, a classic example here is a soccer ball is kicked at a velocity of 25 meters per second at an angle of 25 degrees to the ground. And I'm going to find out several things here, but the first one is find the maximum height of the ball. All right. So again, here's the situation. I'm going to go over here and just kind of draw it out. But we have a soccer ball kicked at 25 meters per second, just like that. And there is a 25-degree angle. Now this ball continues as any soccer ball would, and eventually it comes back down. All right. Now I want to find the maximum height of this ball. Again, because there is projectile motion, I'm going to write down my variables here. So I've got my x variables, where I have v1x, vfx, sometimes called v2x. We have our ax. We also have our delta x. And let's see, now I got my y's, where I'm just writing down the same thing here. So I've got my v1y, vfy, ay, and delta y. And of course, the bridge, delta t. All right, now I look at this information, I try to figure out what I do know. Accelerations. I actually do know both those accelerations. And just like my cannonball in the first example, my AX, my acceleration horizontally, there's no wind. There is nothing pushing this soccer ball. There is nothing pushing against it or for it. And so your acceleration in the horizontal plane is 0. But in the vertical plane, of course, we have our good old gravity, which acts down. And so I've got a negative 9.8 there. All right. Now, in terms of what else we got, I think that's it, except for we have our first initial information here about our velocity. Now, that is that 25 meters per second at a 25-degree angle is our V1, completely our V1. But what we can do is use trigonometry, which I know we all love, to break apart V1 so that I can find the horizontal component of it and the vertical component of it. And so I'm going to do that with a little bit of, like I said, trigonometry. And so my V1x would be that right there, and my V1y would be right there. And so again, using a little bit of trigonometry, let's see here, which one am I going to get first? Let's go with the vertical. So it's the opposite. So I'm going to use sine of 25 degrees is equal to my V1y over the hypotenuse, which is my 25 meters per second. I do a little bit of trigonometry there, and I find out that V1y is, let's see here, is in fact 10.56 meters per second. So that would go right in here. 10.56.
Mr. Right. Gates?
Yes.
The angle in the note is 35 degrees. Just wanting to confirm which one it is.
Okay, I did change it, did I? Okay.
Yeah.
All right, I'm going to change that back then to 35. You know what's happened is, and this what I'll do sometimes is, it's fine with 25 degrees, but I probably put 35 because I don't like the 25 and the 35, or two 25s. So thank you. I'll put that back down to 35.
I saw 25 degrees on the note.
You saw 20?
I saw 25 too.
You saw 25 too? All right, so it is 25.
Yeah.
Okay. I would do that. That's something I would do. I would switch it back to 35 after teaching it once because I don't want the two 25s getting mixed up. So I guess I did do, I left it at 25 then. So that's okay? Okay. So it is 25. Because again, that's something I would do because I right when I look at this question, when I first look at it, I go, I don't like having two 25s because you don't know which 25 I'm working with. So because the angle and the speed or velocity are the same. All right, but I guess I did leave it at 25. All right, so again, I'll go and go after my horizontal component of my initial velocity. That is the adjacent side, so it'll be cosine of 25 degrees is equal to V1x all over the hypotenuse, which again is that 25. And again, do a little trick. I got V1x, and let's see here. I end up with 22.65. All right, so we'll put that right here. Okay, now again, when your acceleration is 0, that means your velocity is not changing at all. And so if my initial velocity is 22.65 horizontally, then my final would also be 22.65. All right, so there's the information I've got so far. I haven't even got to the question yet, which is find the maximum height of the ball. All right, so because this is multi-part, I'm going to put a little A here. And this again comes back down to, I think we did a question like this at 9 o'clock, where if you're looking at your maximum height, then that means vertically your final velocity is 0 because it's reached vertically. It's not going up anymore, and it's not even going down anymore. It's in the middle, which means it's 0. All right. So what do I want? The maximum height. So I'll put A there because, again, I got multiple parts. So I want my delta y when my VFy is 0, and the rest of it is not changing. All right. So, again, I go my formula sheet. I need a delta y, but, again, that's substituting in means delta d. All right. So I need an equation with delta d in it. My first equation doesn't have it. Gone. Second equation. I got delta d. I need the vi. Got it. Don't have delta t. All right, hopefully I don't have to do that again. Third equation. It's got a delta d in it, but again, I'm missing delta t. All right. Uh-oh. All right, let's see here. Fourth equation. I got my delta d, I got my a, I got my vi, I got my vf. All right. So I'm going to use my fourth equation, which is vf y squared. Again, you got to convert them. V1 equals V1 y squared plus 2ay delta y. There we go. So again, that's just rewriting that fourth equation in terms of its vertical components. All right, so I'm substituting in. So my VF is y is 0. My V1y is 10.56. And I'm going to square that. Plus 2 times my acceleration, which again is negative 9.8, times delta y. All right, so let's see, 0 squared is 0. 10.56 squared. It's got to be 100 and something. Let's see here, I got 111.51. 2 times that negative 9.8 is negative 4.9 delta y. All right, things are getting simpler. I'm going to move this term, this negative 4.9 delta y, over to the other side so it becomes a...
Sorry, 2 times negative 9.8.
2 times negative 9.8 is negative 4.9, is it not? Oh, yeah, sorry, that's half of it. Thank you.
No problem.
That saves me the problem because I don't want to carry out a mistake. So I did half in my head. So negative 19.6. What you'll find with me a lot of the time is I'm not looking at my notes, my answers. I just do the question. That way you can hear what I'm thinking while I'm doing the question. So always seems to work for me. But thank you for catching the mistake. I'm moving, same idea though. I'm moving that over. It is a 19.6 over here now. Equals 111.51 divided by my numerical coefficient. And let's see, our maximum height. It's a good thing it's going to be a positive number here because it should be. The soccer ball is going on its way up, and I'm getting 5.69 meters. There we go. Which kind of makes sense. Soccer kick like that. All right, so that is A. That's our maximum height. So that's up here. Right up in there. All right, now we get to B. Totally different. So I'm going to erase this. I'm going to keep my variables obviously here. I don't need this trig anymore because I've got that figured out. So we'll get some of that gone. Give myself some more room. All right. All right, so now I'm on to B, which is find the time it takes for the ball to land. All right, so let me see. So this is B now. I want the time. All right, and for it to land, which in this case would mean my delta y, would be 0. Because your vertical distance, you would have no height. All right, so we're looking for time. Now we have a green. So I'm going to ignore these red values because they are for question part A, which again is up here. But in B, we're talking about the ground, which is right there. All right, so again, going to my formula sheet here. Let's see here. So again, dealing with the green. Red doesn't count anymore because that's A. So I need my delta T, first equation. It does have a delta T. I need the A, got it. I need the VF. I do not have that. I do have it in A, but do not have it in S. So can't use it. First equation, second equation. It's got time in it. All right, delta D, got it. VI, got it. A, got it. I could use the second equation, but here's what I'm seeing. It's got a delta T in it and a delta T squared, which means I'm going to have to use a quadratic formula if I go that route. Let's see. We'll go with, do we have to do that? Let's see. Third equation. Delta D there. I got the VI, don't have the VF. All right. Fourth equation. Doesn't even have a delta T in it. Oh no, I'm gonna have to go with the second equation here. That's not good. All right, so let's plug that information in. I could also, if I use this information, I'm gonna have to use a quadratic formula. What about up here though? Never checked that out. I don't think it's gonna work either. All right, unfortunate. All right, so something's messed up here. What am I messing here? Am I going to have to use that second equation? Huh. I could, but there is a little bit of a trick I could do. Man, what's going on here? All right. Well, I guess I'm going to have to use a quadratic formula. I didn't want to. Here we go. All right, so I've got my second equation, which is, again, converting delta y is equal to V1y delta t plus 1/2 ay. There's that half that I'm looking at, delta t squared. All right, so let's see here. Substitute in my value. Delta y is 0. V1y is 10.56. Delta t, I don't know, plus 1/2. Again, I'm going to put that down as 0.5. My ay is the negative 9.8. And delta t squared. All right, continuing on here. So let's see here. Solve. I got 0 equals 10.56 delta t. Here's what I'm used to. I get the half times negative 9.8. There's my minus 4.9. Delta t squared. Now I do have a delta t and a delta t squared, but I'm getting lucky here. I already have a 0 on one side. So here's a little bit of a different way to solve this. I'm getting lucky. I don't have to use a quadratic formula. I'm going to factor out a delta t, common factor out. So there's my delta t. So in brackets here, I'm going to have a 10.56 minus a 4.9 delta t. So I just factored out a delta t. Now, when you do factoring, and I have a 0 on one side, I set two pieces equal to 0. And so I've got one here, delta t equals 0. Well, yeah, that makes sense. When is the ball on the ground? At the very beginning. Now my second answer is going to be when it actually hits the ground over here. So this answer is when it gets kicked. The second answer is when it hits the ground at the end. So I get 10.56 minus 4.9 delta t equals 0. I'm going to solve that equation. So I'm going to move my negative 4.9 delta t over to the other side, which of course makes it positive. All right, and I divide both sides by 4.9. Marker's running out of ink here. And my delta t is equal to, let's see here, I get 10.56. Where'd my calculator go? There it is. 10.56 divided by 4.9. And I get 2 decimal places, 16 seconds. There we go. All right, so I actually didn't have to use the quadratic formula here because I had a 0 here already, which is good. So there's the time it hits the ground. Whew. All right, now we're on to C. How far horizontally does the ball travel? All right, so that's going to help us here because we know it takes 2.16 seconds to hit the ground. And what we're looking for is how far to the right does it go, which again refers to our horizontal components here. So I'm looking for delta x in C. All right, but I actually know that delta t here, whoops, I'll put it right here, is 2.16 seconds? Yeah, 16 seconds. So now I'm looking for delta x. How far did this thing travel to the right, horizontally? All right, so let's see here. What formula do we have here? We're looking for delta x, so the first equation doesn't work. Second equation, we have our delta x, we need our VI, we got it. We got our delta t, okay. We need an a, which we have, and a delta t squared, which we're gonna have. All right, so I'm gonna use my second equation. All right, so I've got, again, converting it to vertical or horizontally, writing it down. So instead of delta d, it's going to be delta x, which we're trying to find is equal to v1x times delta t plus 1/2 ax delta t squared. All right, so here we go. Let's see here. So I've got delta x. That's what I'm looking for. V1x, 22.65. All right, our delta t, again, that's what we found in B, but it is related to C because we're talking about the same point. It's going to be that 2.16 seconds. Plus half, again, 0.5. My acceleration is 0. And again, my delta t is that 2.16 squared. Not like it's going to matter anyways. All right, so now delta x, I've got 22.65 times 2.16. Yikes, I'm gonna have to, that's definitely a calculator one. And I'm getting 48.92 meters. Plus, well, 0.5 times 0 is 0. Times that 2.16 squared, it doesn't even matter because that whole term's going to be 0 because we're multiplying by a 0. And so this ball travels like half the soccer field. We have 48.92 meters. All right. Whew. Now what's up? D. Oh, here we go again. Let's see here. What is the final velocity of the ball when it hits the ground? All right, so get back to all right, so what we're looking at is the final velocity, and we did this in our last example. Oh, that's so wet. Where our final velocity, we're looking at a ball strikes the ground. That would be considered our VF. All right, and again, when we're looking at our VFX, our horizontal component of that final velocity, we already know it actually. It's 22.65. That's our VFX. But of course, it also includes, we need to know our VFY. All right, and if we can put those two together, find the angle with the ground. All right, now, here's the trick of it all, is that when you are dealing with projectile motion, and if the object lands in the same spot or same level that it was shot from, these two are going to be the same, and so are these two. So your final velocity is going to be 10.56, but it's headed downwards. So that's something that happens. It's just like if you throw something up at 10 meters per second, when it comes back down, it's going to hit your hand at 10 meters per second, as long as you didn't change the level of your hand. Because the same rate at which it's being slowed down, 9.8 meters per second squared, is the same rate at which it is being sped up, all right? Because it's traveling the same distance. And so our VFY is going to be negative 10.56. Or we could just look at the magnitude as being 10.56 because it is moving downwards, all right? And so again, I can use the Pythagorean theorem. VF squared is equal to, I take my 10.56 squared, or negative, it doesn't matter because we're squaring it. I'm just worried with the magnitude of it. 0.65 squared. And you find out that if you did that, guess what? Because again, the ball is landing on the same level it's kicked from. It's going to be the exact same velocity that we started out with. And in fact, our angle is going to be the same angle that it lands with. Again, this is when your object, its starting position, lands on the same level, so vertical as before. And so your final velocity of your object is 25 meters per second at an angle of 25 degrees with the ground. So that's something to watch out for. All right, so if your object lands in the same level, your final velocity and your initial velocity will be the same, except for they're going to be the opposite in terms of your vertical velocity, because your horizontal velocity is going to stay the same, but your vertical is going to flip from going up to going down. And there we go. So our soccer ball is hitting the ground with the same, well, kind of the opposite velocity, but the same magnitude. Again, because they're on the same level. And there we go. All right, so that is, again, projectile motion. Looking at, again, mixing up some of the things that we looked at with maximum height. Try to throw all the different scenarios at you. But again, the key here is make sure you separate when you have a multi-part question. Don't mix up your variables, because in here, in A, we were looking for the max height, but in B, we were looking at a different situation where we were hitting the ground. All right, so let me hit the stop button.